Okay. So now you have you can open this workshop this hands-on file, and I hope you have download this file in your local folder. So let me delete my practice and start from scratch. So unzip this here. So let's first enter this file, this script, and it will consider the. I think now you are quite familiar with this data structure. You have this one to consider for the DFT and DFPT calculation, and you will have TDEP and SHA here. But for here, we make deal of DFPT. So we'll generate in this. We will first generate the three EPR file with DFPT phonon, SHA phonon, and TDEP phonon. So and we will plot them. And I think that I should show the result before talking about this. We will generate this figure and after at the end of this hands-on. Okay, so let's look at the this hands-on. First of all, let's start the Docker. Let me find. Let's see, it's my script. Okay, generate stock and this Docker and goes here. Then the first step is generate the EPR file using DFPT phonons. This is the baseline. I think you have practiced this several times. And we just make this and let's copy this Vim QE to perturb.in. And then we should link the SCF stuff and Warner stuff here, but you can just copy my script. And then we run this. This would take like 3 minutes, and you guys can have time figuring this out. Huh? Okay.
So for TDAP and SHA, you have like a practical advice on which one is better for what types of materials?
I okay. I don't know. I think they are quite equivalent. Yeah, yeah. I don't know. I use either and yeah, I think they're quite similar. I don't have a preference. Yeah. I always do self consistently. Yeah. I'm I'm using actually I prefer to use a la mode. That's it's just my just this the script is should suitable. It's more the source code is more editable for me because you know if you do research you need to change the code. You need to read the code. So the code for me is more readable because it's C. It's yeah, it's just my experience. Oh. Yeah, it's another package that will be supported in the future. It's also on a harmonic phone now. Okay, it's finished. And actually, if it's not finished, you can just stop it because it's okay. Because actually, most of the time is spent on transforming the electron phonon interaction. But in this hands-on, we will only plot the phonon. The phonon actually is generated in the first few seconds. Okay, so yeah, it's okay. You can just Control C and stop it. Let's do the next stuff. Okay, next one is to generate EPR file using TDEP force constant. Okay, then let's go to TDEP, and here we have supply the output file from TDEP, which will be input file for Perturbo. One is in file UC postcard, and which is the crystal structure information in TDEP format. This one is a force constant from the TDEP. So these two files, and you can look at the TDEP website for its structure. And let's look at the QE to perturb in. There are some differences compared. There are very small differences. So basically, you only need to activate this one. TDEP equals true. So that's only changes in the QE to perturbo files script. Yeah, that's only changes. So it's kind of easy to use. And then for the same thing, you need to make the deer. You need to link the NSF files in the temp and also link the 1-year file. Okay, and then run the script. For example, you see here, there is a line called saved electron and phonon data to the file. Actually, after this, you can stop the code because the rest of part will be calculating the electron phonon matrix element. Uh, yeah, which will not be covered here, but it covered previously. Yeah. So I just stop this. It is safe. Okay. So the last, not third one is to generate the force constant. Use the force constant for SHA, and there for SHA, it's a little different. So we should first go to this SHA file, and this is like a particular directory that if you are working with SHA and TDEP and the Perturbo, where you have this full script. Actually, this script are using are heavily relied on SHA code. So, but we provide this. We did some extra scripting, and after the iteration, you will need to collect this data and transfer and then in a separate folder in preparation for Perturbo. So for that, you should change mode as X. This makes it to be executable, and you enter U plus. This is asking you number of the phonon files, which is 10. After running this, you will have a phonon folder inside this, and these are all the files. These files will be used in the QE2 Perturbo process. And this dynamical matrix also in the XML format, but it is rewritten by the SHA force constant, by the SHA dynamical matrix. QE2 Perturbo SHA. Oh. So let's see the file. Actually, comparing to the DFPT case, nothing is changed except the directory of the directory of the information of the force constant information and deformation potential. So yeah, so all the same. Okay, then copy this, link the NSA file, link the 1-year file, and then do a calculation. And then you have this line, save the electron phonon data to files. With this, you can stop the code and you have the EPR file here. But it only contains electron and the phonon. To have electron phonon interactions, you should finish the calculation. Okay, so we have generated the EPR file with three different version of phonon dispersion. Now we are going to comparing them. Okay, let's go to Perturbo file, Perturb EPH here, and then you need to copy my script. I prepare a script. No, yeah, copy this script. So let me explain the script. This script is a link the EPR file from DFPD, do the calculation, and copy the phonon dispersion file, rename it to another one. And for TDEP, do the calculation, rename to TDEP. And for SHA, do the same thing. Okay, so you can just copy this and boom. And then we generate three phonon dispersion YAML file. This one, SHA, TDEP, and DFPT. Now we are going to comparing them. So for this one, copy this source code. Copy this code, but actually the first line should be removed. Then plot py. Go to first line. Delete it. And yeah, let's look at this code. So basically, this is using Perturbo Pi for the post processing, and yeah, okay. So Python 3 plot. Okay, plot is generated, which is called compare pH dispersion PNG. I need to open it. So it's Perturbo from Perturbo, and okay, then we generate this file. And yeah, these blue ones are DFPT phonon dispersion. You can see it's have an imaginary frequency, and it's a TDEP. In red is for TDEP. SHA is the red. It's the green one. They are more or less the same. And if one do the calculation carefully enough, you should get pretty good agreement between the two algorithms. But in TLab, sometimes you sample the configuration from MD. In that case, you will get different dispersion comparing to converged SHA calculation. So yeah, but but they are of the same level of approximation. I hope all of you get this plot, and that's end of the hands-on session. That's a target you are aiming for.